And at this point, I will turn it over to my good friend at King's College, Marc Modat. Marc, take us away to talk to us about machine learning in XNAT.
Sorry, just making sure I was on mute. So we'll be speaking about supporting machine learning with XNAT. And as you all certainly know, machine learning and especially deep learning nowadays is becoming ubiquitous in the field of medical imaging. And we are using it for all tasks, well, registration, segmentation, diagnostic, monitoring, prognosis, and so on and so forth. So as sort of ML took over the world, XNAT evolved to accommodate the needs of its community of users. And now within XNAT, as previously presented by Dan Marcus earlier today, we have tools and plugins for all the steps involved in developing learning-based tools. So these steps that Simon reminded us just before the breaks involve data access, data curation. We've got standardization, QC, labeling, and many other things. We've got model training, validation, and finally deployment. So within the next 25 minutes to 30 minutes, with 3 expert panelists, we will discuss this aspect, review some of the XNAT tools, mention the good, the bad, if any, and hopefully come up with a wish list for the future development. So our 3 experts for this session are Dr. Mintz, Dr. Ahmed Harouni, and Dr. Jorge Cardoso. So Dr. Mintz is an assistant professor of radiology at Washington University and the clinical lead for imaging informatics for the Department of Radiology. Haroun has collaborated extensively with Dan Marcus to leverage XNAT for large-scale computational imaging research at WashU, including, amongst others, the use of XNAT to conduct an AI FDA clinical trial at WashU. Dr. Mintz is a full-time practicing radiologist in the abdomen section at WashU, where he engaged in the full spectrum of body imaging, and he also served as a clinical consultant for radiologists and flywheel exchange. And if I understand correctly, from Wednesday onwards, it's going to be a single consultancy job. So we are also fortunate to have Dr. Ahmed Harouni, who is a deep learning solution architect for NVIDIA medical imaging. Ahmed received his PhD in electrical and computer engineering from Johns Hopkins University, where he focused on MR image acquisition and image processing. His current focus is on bringing AI into the clinic through the use of NVIDIA's SDK as Clara Train and Clara Deploy. And finally, Jorge Cardoso, who is a senior lecturer at King's College London, where he leads the Artificial Medical Intelligence Group, AMIGO. George is also the CTO of the London AI Centre for Value-Based Healthcare, which is a large initiative in the UK to promote the training and deployment of AI tools within the UK National Healthcare System Trusts, within the different hospitals. George is also one of the, well, let's say, father of the MONAI project, and he is part of the advisory board. So, as I mentioned, we will discuss the different steps of machine learning and see what our expert panelists think about, well, the XNAT integration. So in terms of question, I will try to monitor all of the different windows I've got in front of me. Likely I will fail, so we will come back towards questions that I missed at the end. So coming back and starting with data access. So access to large amount of data is often key when it comes to machine learning, as you all know. And there are currently several means to populate XNAT with imaging data. We were discussing that on some of the chat and Q&A. So you can use DICOM push, DICOM pull. We've got a desktop application. We can use the rest if we want to write Python or Bash script. And so the question I've got for the panelists is that I would like to know if you think that XNAT is currently missing important features to input data that could help us to run a machine learning algorithm. So Haroun, I can see a yellow box around your screen. So do you want to start addressing this point?
Yeah, I think in my experience, one of the powerful features of XNAT is our tight integration with our sort of imaging infrastructure, enterprise imaging infrastructure. We can go very quickly from developing a cohort to importing that from the clinical archive into our repository and spinning up a project very rapidly. So it really streamlined that workflow. I think that one of the, and it's made, we've done a tremendous amount of research, and it's been very exciting and very powerful compared to, everything that was possible up until, we started working with this. I do think that one of the things we're starting to encounter is that even if there's a lot of metadata associated with clinical imaging, with radiology, with the actual images, the reports, which you can, in some cases are available in the archive. There's billing data, there's other clinical metadata that is sort of really key to contextualizing the images, to correlating diagnoses, to sort of inferring outcomes. And a lot of that is easily available, if you can plug into existing HL7 messaging within a clinical enterprise. And so I think HL7 integration, I think skipping to FHIR, HL7 FHIR really makes the most sense. We're sort of playing around with, sort of legacy HL7 2 and 3 specifications, and, to call it a standard is sort of being generous. But I think that would be exceedingly powerful. And would really augment our ability to sort of combine some other clinical data points. You can infer a lot about clinical diagnosis outcome just from the reports alone, and from some NLP. But to incorporate a little bit of metadata that's coming from the HL7 messages that are associated with the imaging instance. Someone gets a study done, and just the billing data that has to be transmitted is rich with demographic information. With diagnoses that are necessary for billing. It's going to vary depending on, where you are. In the US, it'll obviously be different from Europe and elsewhere. But I think that would be exceedingly powerful. And, and as we move forward, Epic is becoming the dominant EHR provider here in the United States. And they support all sorts of HL7 FHIR interfaces. And so it's becoming easier, I think, to get access to that clinical data. You have to overcome regulatory hurdles within an organization. But I think that'd be the next step. Because that is where the real power lies. The images out of context are useful, but they're so much more powerful if you on the clinical data.
Thanks. Basically, so ideally, we would like to run away from having to generate a CSV file of all of our patients, all of our data, and uploading everything, which I may have used quite recently. So moving on, but still on the data of acquisition. On one side, now, done with things that in WashU, they hooked XNAT within the packs. So they've got access to, I think it was mentioning something like 20 million plus data. While if we look at the projects that XNAT, or that at least most of the users here are dealing with, we've got at most a few thousands of subjects. So we need to be able to scale. So I know that we had our frustration with that type of thing, George. So I'm going to look at you and ask you if you want to make any comments. Can't hear you, George.
Can you hear me now?
Yeah.
Okay. So so just very quickly on that front. I think it's really interesting to see where research is going. Obviously, we started by looking at relatively small cohorts. I think most people were initially using XNAT for that purpose. But research is going more in the direction of being able to utilize all of the information that exists in the packs. And sometimes you don't necessarily know in advance what you want or what you need. And your ethics actually allow you to do large-scale searches and large-scale queries and large-scale processing at the full packs level. So, for example, as part of our AI center, we're really trying to almost do a full data dump of the packs into a secondary research system, which can then later be mined and queried and labeled and processed so that we can then do better and more research on top of it. And some of these aspects are sometimes a little bit complicated because the infrastructure had to move from something that was designed for maybe a couple of thousand of data sets to now having multiple millions of images. For example, our Neuro data set now comprises more than 2 million volumes. It's roughly 300,000, I think, series, but 2 million volumes. And the systems start lagging. And I think it will be really interesting to think about how could a system like XNAT could really work as this sort of research interface for everything that is happening behind the scenes either via directly replicating the full packs and making it searchable at scale with all of the capabilities that that should have, but also as a mechanism to try to standardize how that data querying happens, how to optimize what data gets stored and what data gets cached and what data can be pulled or synchronized from the clinical systems. I think it will be really interesting to see how the platform should evolve to be able to accommodate this new use case.
So we are effectively asking the team to hook dynamically to the EHR and all of the packs in one go, so that we can do that without crashing the hospital. So that's good. That's a small challenge. So once all of that will be sorted, that means that we'll have all of the data we want within XNAT, and then we can go to the next step of the process, which is data curations. So data curation as a whole is also an important aspect of any data processing pipeline, as we don't want to fall into the concept of garbage in, garbage out. So we need to be careful with the data we use, especially when we know how dirty the data acquired in clinical routine can be, as opposed to clinical research or even clinical trial. So there are a lot of tools that were presented by Dan a bit earlier today that are currently available in XNAT. And I was wondering if any of you would like to comment of some of these tools. So Ahmed, I know that you've been working on Clara Annotates and we haven't heard you yet. So maybe you want to take this one first.
Yeah, so we thank Simon for actually integrating the Clara AI, the assisted annotation out of the Clara platform into the OHIP viewer. So with that ability, you can actually use any of the models that exist already in Clara, like segmentation or like the assisted annotation, where you give it like guiding points. Or we have other models that are like deep grow, where you give like just seed points, and then it will segment the organ or the tumor that you actually have on that patient, and then you can store those for the next round of training. For maybe another point where this is all in XNAT, where you want to get the exact cohorts to generate some of the files so that you have a data set so that you can actually train on in the next round of Clara. That feature is also available in XNAT.
Good, thanks. So you mentioned the HIF viewer. Surprised that at least you did not mention my frustration with that, is that it only works with DICOM, and you didn't give a hard time to Simon for not supporting Nifty there. That would be on my wish list. So, but we've got a lot of tools as well within XNAT apart from that. Well, Arun, when we were discussing a bit earlier, you were mentioning about some of the frustration that you've got when you need to inspect the data. Basically, that it takes a lot of clicks, and we wish we could find something a lot easier or more straightforward.
Yeah, I think one of the strengths of XNAT is the ability to set up these sort of pipelines. So as you for instance, the anonymization, it's easy to containerize a process and to execute it and do some pre-processing of data as it comes into a project. I think one of the challenges, though, is that you don't, that works if you know what you need to do, on the front end, and also works if you know what your issues are with the data as you import it. I think one of the challenges, especially with these larger projects, is inspecting the data and interacting with the data within the user interface, within XNAT. I think going forward, figuring out how you visualize your project, how you sort of look at the outputs of some of the containers you may execute if maybe you're looking at texture analysis features across multiple studies, and how you begin to interact with that data and do it within XNAT. And I think that'll be important, because you're gonna run into issues related to the data quality, related to noise, and to quickly interrogate those and troubleshoot those will require your ability to navigate within the experiments, within the metadata, navigate the the RStruct files to visualize them quickly within the interface, to look at the outputs of your texture, your radiomic models, let's say, and look at those statistics. And I think that'll, to the extent that is doable within the user interface and can be fast, will really facilitate your ability to kind of iterate through and figure out what your challenges are, and then say, okay, we clearly have this issue with our data set. We need to go ahead and, you know, write some scripts to clean it up, so that the next import doesn't have this issue. And I think that's sort of the challenge, which is navigating the data, exploring the data, understanding your cohort with it. You know, once you identify those patients or those experiments, those images, I think is one of the challenges going forward. And it's complex because that requires, you know, it's a lot of work. I mean, you're talking about image viewer, you're talking about, you know, data visualization, statistics, you're talking about exploring DICOM metadata, maybe clinical data. And so it's very complex UI.
Right.
But I think that,
yeah, and all of that potentially on thousands of scans in
right, on
the best
tens of thousands, 50,000, 100,000, right? Like you said, you may have a cohort of 2 million patients, 2 million studies. So, you know, that's a huge implementation challenge.
Yeah,
which is not my area of expertise. So, but I think to the extent that you can, you know, to the extent that you can do that, even at a higher level, would be useful.
Yeah, and I mean, some of the initial challenge that we've got when we take the clinical data is basically even the sequence name, it's pretty much all over the place.
Yeah.
And so we've got challenges to know what is what. So George, you wanted to comment on that?
Yeah, absolutely. I just wanted to comment. I think everything when it comes from bringing clinical data into a research-ready format, let's say it, there's a process of transformation and data curation which needs to be automated. And obviously there's heuristic tools at the moment, things like, for example, the sequence type matching and things like this, that allow you to make some sense out of the data that you have. But those tools can only go that far, right? There are certain things you cannot really map just via matching names. For example, within our hospital in KCH, we have more than 14,000 brain MRI scan sequence names. You're not going to do a mapping for each one of those because you'll be there forever. But this is just an example, right? So, and I think a possible solution for this is to try to introduce machine learning and AI as part of the curation process through an active learning process where humans are using the system, and as the humans are using the system and labeling data, the algorithms are improving what they know about the data and making better predictions and automating the labeling process itself. And I think it will be interesting to think about how can algorithms start replacing heuristics, still through the use of humans in the loop and still with humans guiding this training. But I think it will be really interesting to see where the community can go when algorithms start taking over some of these heuristic decision-making processes.
Good. So we are effectively reaching a point where we managed to import our 20 million scan. We've been curated everything, and now we are coming to the core of the job, which is about doing the modeling and doing the training. So once we've done all of that, we want to create our data sets so that we can do training, validation, and testing. And do you think that XNAT enables you to do it the way you want? Do you wish there were any extra features that could be added to the platform, Ahmed?
Yes, that's actually a very challenging task. So as a data scientist, you wish you can actually find all the images that first qualify for annotation and then see if that annotation is done already. And if not, you need to actually see how like you can assign that to a radiologist or something to like annotate that. So that feature is there for it's not 100% there, but like you can kind of get to maybe like 80% by like creating data lists. But the part that you touched on like is basically I want my data set to be like balanced. So you need like the different age groups, the different demographics, different male-female ratio. And more importantly, if you are in oncology, for instance, and you have like tumors, you need those tumors to be in different locations with different sizes. So that part is still like hard to like quantify and have. And again, if you it's even hard if you have like a small data sets in the hundreds, but again, if you go larger scale, that's still like a challenging part. So yeah, that's definitely one part that still needs a lot of work.
So, but what will it take to do that? Because at the moment, if we've got all of this demographic information, we can create massive table and we've got the listing. Will it be the case of simply adding some more visualization on the top so that we could look at distribution of this data across different subgroup, or do you foresee something more complex than that?
You are right. The demographics part is there, but like you need the part that's like mapping like the annotation or the tumor location and quantifying the sizes or like how many in each of those studies so that you can actually extract those into a data set and then start a training job on it.
So at the moment, should someone want to do that, they will need to extract all of the data from XNAT, do their selection, and then go back to XNAT.
Yeah, you either extract or you need to maybe take the DICOM segs or how what is the segmentation format that you did, and then do some processing on it so that you actually can like balance your data.
Good, thank you. Moving up to the next step of the pipeline, which is actual training. I went a bit ahead of myself before. So on the training side, at the moment, it seems fairly tight to Clara, which is not a bad thing at the moment, but me being fairly completely biased and having George here as well with me, there is a little one that's coming up, Monai, and it's work that's done in collaboration with NVIDIA. So what do you think could be done there, and how might they, I mean, it's not about using one tool or the other one exactly for the same purpose. How do you think they could be different from one another?
No, absolutely. Yeah, I can probably try to answer a little bit of that. So I think what's interesting about Clara is, so Clara, as many of you probably know, before it was actually based on their own internal ecosystem, but now the new releases of Clara Train, they've actually been moved onto the Monai stack. So the underlying algorithmic stack within Clara Train is actually based around Monai. It's just Clara abstracts extra things and provides kind of end-to-end configurable pipelines. But I think the more interesting question is not so much about the stack, but how do we go from data, which is now curated and labeled and appropriately stored and etc., into the development and creation of algorithms that can learn to map inputs to outputs, whatever that means for any arbitrary piece of data. So for things like images, we relatively know how to do that, right? We know how to learn segmentations. For example, the Decathlon challenge, which ran a few years ago, has shown that a single model, a single algorithm, can learn 10 completely arbitrary different tasks without changing any parameters, without any human interactions, just by changing what the inputs and outputs look like. And I think what will be interesting is not only to have the frameworks, the computational frameworks in the software, to allow for us to say, these are the inputs, these are the outputs, learn to map one to the other, but also for the science to follow and to develop better and more flexible architectures that can solve that complex problem. How do we go from inputs to outputs without having to have a researcher hand coding or adapting an architecture to a very specific problem where the compute system is the one doing that work for you. So I think it's both a combination of the software stack around it, providing the data in a format that is expected, the software that is running the algorithms being amenable to work with any kind of medical data and make predictions of any kind of medical data, but also the science evolving to be able to create architectures and models that are able to map inputs to outputs with very little to no human interaction. And if we get those three pieces of the puzzle, then in theory, we can get almost arbitrary input to output mapping, which will solve many of the problems that we would like to solve, I think.
Okay, thanks for that. But so elaborating on that, so now we've got our train model, we want to deploy them, sorry, I'm trying to come back to what you were saying about the input output. At the end of the day, we are not really doing a medical device here. We can't use any pipeline on any type of data. So if I've got something that is detected as a T1 weighted MRI of the brain, should I send it to my stroke pipeline? Should I send it to my dementia pipeline? Should I send it to my oncology pipeline? Because it's not going to be trained for, we are not at a stage where we train one model for all of the diseases. So how do we deal with that without ontology?
Absolutely. So that actually goes back to what I was trying to say before about the the labeling processes and automating all of those. Because at the moment we want to say this is a T1, this is a T2, this is a brain, this is whatever, because we want to then feed that data to train a model. But actually the same kind of questions are important from the point of view of knowing what to run. So there is a phase of discovery. Either you know in advance what you want to run because there is a radiological request that says run this, and you know that there's a request code that knows explicitly what you want to run. But there might also be another setup where a patient comes through and you don't really know what the patient have, or the request code is not attached to the data, and the data needs to go through a discovery phase, which again is going to be comprised by a series of algorithms that try to figure out what the data is and what can be done with the data. For example, if the model knows is the brain is has a T1 and a T2, and there's this blob thingy there, which might be a stroke, maybe I can run my stroke pipeline, and if the clinicians want to look at that result, then the result will be ready. So I think not only standardizing those pipelines, but figuring out how do we go from raw data and pipelining and routing that data into a specific workflow or specific algorithm, and what will be the intelligence that is needed for that to happen. At the first stage, through a series of heuristics, which is what mostly happens in most PACS execution environments, and in the future with a series of algorithms that could ask much more complicated questions, we would then be at the stage where we could start running containers or running workflows out of the box with data that has the appropriate characteristics for those.
Yeah, tomorrow we'll do that. Sounds good. So we are on the topic of using it on prospective data and deployment, and I see that I've got a few yellow box coming up. Arun, did you want to make a comment there?
Well, just to touch on that, I think one of the key things there, as you get into the bringing in sort of arbitrary clinical data and wanting to do direct, images themselves to real-time processing, some of the context, the clinical context and the metadata is going to be key to sort of helping your algorithm, your models learn what the appropriate analysis, what the appropriate execute, basically what to do with the output. The same, example is the same, the patient presenting with a stroke may have very similar imaging findings to someone presenting with a brain tumor. And so context will probably be everything. There's tremendous overlap in a lot of the imaging. And so some of the clinical context, I think, will be key on the front end as you sort of, train these more dynamic models that can deal with arbitrary studies coming in and don't need to know a priori, this is stroke imaging, but rather can determine what the appropriate, not only the appropriate, it may not even be that the output is different, but that the final decision making, the sort of final analysis is based on, what's in the pixels, but also the clinical context, which is what humans, what physicians do, what radiologists do. If you tell me this is the patient's history, then this is the diagnosis. You tell me this is the patient's history, this is the diagnosis. And so I think that sort of gets back to the notion of needing to incorporate some of the context, regardless, but the images themselves are out of context, not necessarily that helpful.
Yeah, it's coming back to the discussion we had at the very beginning. We basically need to pull the EHR with the imaging data, and the imaging data are one feature. With a lot of data points, but it's part of the story, and we need to correlate everything together. And so coming back to this deployment engine, do you have anything on your wish list that you think will be done to try to improve the usability of XNAT as a deployment platform? Ahmed, do you want to comment on that? XNAT as a deployment platform, what should we do?
So I played around with some scripting that can actually talk to the assisted annotation server, because it's still a server that can actually run models. So you can pass on a project or something that it can run on. It still have some issues that you're sharing user and password in plain text in the scripts to actually get those to runs. We've also played with some kind of pipelines that can actually trigger Clara deploy pipelines to run on multiple models, but it's not that straightforward to actually run and get back the segmentation and associate that segmentation with the study that was initiated from. So those are a couple of things besides what I mentioned before, and making like the extracting of the data and knowing like again how to make the balanced data. Those are the main three things that I wish like can be easier in XNAT.
Good, thanks. And well, we don't really have a question related to the topic we've been discussing on the Q&A, so I will ask a final concluding question. So XNAT per se is not a medical device, and when we are using it for deployment, we are, I mean, in the UK, we've got in-house exemption so that we can use our own code. I think in the US, there is a similar pathway. It must be the same in other countries. Sorry, I'm only familiar with the UK and a bit of the US here. But I mean, final question is that is XNAT the platform that we should be targeting for deployment in the clinic? Arun?
I mean, I think, and I think this sort of goes to kind of some of the work that Dan did as part of Radiologics with Radiologics and now it's sort of Flywheel, which is XNAT is essentially in production in the clinic in some cases, and the requirements associated with conducting FDA, regulated clinical trials is very similar to the requirements that go into, essentially a medical device. And so, I guess to sort of answer the question, I mean, XNAT does function in that capacity. It certainly can. I think it makes a lot of sense if you're going to be to have an end-to-end ecosystem from initial conception of a research project to building ML models, to fine-tuning those models and validating them, to deploying them. I think XNAT is in some cases already supports kind of that whole path. I mean, I think there's some blanks to fill in, but that makes a very compelling case and certainly solves a lot of problems in terms of being able to go back and forth where you want to do some degree of clinical deployment, but you want to capture, as you begin to deploy a model in the clinical environment or a pipeline in the clinical environment, you want to capture feedback from the users. You want to do retraining. You want to have this sort of constant feedback to retrain. And doing that within one ecosystem, I think makes a lot of sense. So I guess to flip the question around, certainly you can do this with anything, but I think to do it with XNAT, if you're going to be doing research, your research and a lot of your development in XNAT makes a lot of sense to leverage it for clinical deployment to the extent that you can. That sort of answers the question.
Yeah, good. I think that's a good concluding remark. We can use it from A to Z for all over the place, which is good. So because we are running out of time, Ahmed, Haroun, and George, I'd like to thank you for taking part in this actually went quite quickly, short discussion. And thanks a lot for your time. And with that, I would like to, I guess, give the floor back to Yash, maybe, or Dave.